Good morning and welcome everyone to this webinar. We're happy to welcome you to this seminar called Reconfigurable Production in the Era of Industry 4.0. This seminar has been organized by a project that is made with TUM, the Technical University of Munich, and the IMT, like the Mines-Télécom Institute in France, is part of the German-French Academy for the Industry of the Future. And you can see that some of the participants have started some video. It's actually the person from the project and also some of the speakers that we thank to join us today. So the aim of the day is two parts. First is to have scientific and industrial exchange on the reconfigurable manufacturing systems, particularly on three main challenges that are sustainability, digitization, and servitization. And so the agenda is here structured according to these three challenges. So we'll have a first, after introduction to the project, of course, we'll have a first session on reconfigurability and digitization with three talks. So thank you to the speakers already. Then we have a quick coffee break. And after it will be a session on sustainability with two talks, the lunch break, because I think at that point we might be hungry, and after a third session on servitization. In the afternoon, the main is to, the aim, is to exchange ideas in smaller groups to highlight some new research project proposals, ideas, or some project that, some points that we need to work on the subject of reconfigurability, reconfigurable manufacturing system. I am Audrey Sacker. I will be the timekeeper of this meeting. So to the speakers, I might interrupt you just to keep the schedule on time. So sorry in advance if it happens. And yeah, I hope you have a good seminar to everyone, and don't hesitate to communicate with us through the chat, of course, and ask questions through the chat also. But I will get back to that a little later. For now, I will leave Professor Dr. Engineer Xavier Delorme to present the project. He's the one leading the lead. He's the lead of the project. So, Xavier.
Okay, so thank you, Audrey, and good morning to everybody. I am Professor Delorme from Mines-Télécom and Limos, and I have been asked to introduce this day of winter school on reconfigurable production in the era of Industry 4.0. And I will particularly explain the link between all these questions and reconfigurable manufacturing system and a current project funded by the German-French Academy for the Industry of the Future, which is named RDS2 Production. So first of all, let's have a look at what we are talking about when we use the term Industry 4.0. I have taken here one document from a French sources, which has been translated, which try to describe the main elements which are involved when talking about Industry 4.0, and to highlight the main link between all these different technology and all the change that could occur taking into account this new paradigm. What is interesting on this figure is to see that actually talking about Industry 4.0, obviously, as many of you may know, is first of all linked to digitalization of company with different technologies such as cybersecurity, big data, Internet of Things, or Logistic 4.0, which are clearly linked with this new digitalization of company. But as you can see here, you have also other topics in addition to digitalization. And one of these topics is indicated here and is linked to sustainability, which is also a major topic for all companies nowadays and is strongly linked to Industry 4.0. And we can also see that more customization means that we will have to offer more services to company, which means that part of the business model will have to evolve toward more servitization, which means that all the elements around this transformation linked to Industry 4.0 correspond to other transformations which are linked to digitalization, servitization, and sustainability. And at the heart of this transformation, you have new technologies, but most of them correspond to reconfigurable systems, which can be defined using advanced production system, the use of robot or cobot, and autonomous vehicles. So as you can see in this figure, actually, all the topics that we will discuss today are strongly linked with Industry 4.0, and the main idea will be to discuss and to work on these different links. So let's define what we call a reconfigurable system, and more specifically, I will talk about a reconfigurable manufacturing system, which has been defined by Koren et al. 2 years ago. Mainly, they present RMS as a trade-off between dedicated manufacturing line, which correspond more to mass production system, and flexible manufacturing system, which are most of the time too expensive and unreliable. So they want to have a system which can evolve from one production to another. And in order to do that, this system has to be based on six main characteristics. The scalability of the system, its convertibility, its customization, its modularity, its interoperability, and its diagnosability. And as you can see, the three first properties are strongly linked to the organization and industrial engineering of the system, whereas the three last are linked to the digitalization. So mainly, Koren has introduced RMS as a serial organization of workstation with a primary conveyor which will put the part toward the different workstation, each of them being composed of several resources working in parallel. All these resources can be different. You can have reconfigurable machine tools, you can have CNC, you can have cobot, you can have human operator, but the main idea is that you can determine for each workstation the number of resources used in order to ensure the production level. And finally, we will have to use things like AGV in order to be able to deal with some specific part or specific case. Okay, so what are we dealing in this topic today? Mainly, if we are looking to the main issue related to reconfigurability, we can see that system digitalization, uncertainty management, and reconfigurable technology are mainly a mean in order to provide new services and to provide something which is more sustainable. So mainly we can see that we have different innovation challenges for the company, and these challenges and the new technology which are available will lead to a new sustainable, serialized and reconfigurable production system which correspond to a strong industrial transformation. However, this new technology and this new challenge are not enough to achieve this transformation, and we will need to have a toolbox with decision-making tools and a clear methodology on how to use these different technology efficiently. And these decision-making tools will have to consider the production system at different level, from the strategical to the operational level. And the main idea will be to have all the tools needed to deal with the whole life cycle of the production system. So from a scientific point of view, we can indicate 4 main challenges which are linked to reconfigurable manufacturing system. The first one is related to the fact that we have to deal with interoperable production component and software solution, for example, digital twin models. And we need to have a framework which allow us to deal with all these components efficiently. The second question is linked to dynamic decision making, and we will need to have different software tool coming from artificial intelligence or mathematical optimization to support this reconfiguration process. The third question is linked to the serialization and the ability to consider new economics models which can deal with the whole life cycle of product and production equipment in order to provide consumers not only new product, but product and services. And finally, we have a last challenge, which is linked to the societal challenge, such as taking into account human, energy, ecological factor, which will lead to a multi-criteria decision making. So I will conclude this introduction by giving you just some element about the RDS2 project, which has been started and which organized this day. Mainly, the basic idea of this project is to work on this link and to determine what would be a useful framework for such a toolbox. And this project, which hopefully will take some benefits from all the exchange today, has been proposed by 3 schools, 2 from IMT, Mines-Saint-Étienne, and IMT Atlantic, and from the Technical University of Munich, TUM, in Germany, and has been funded by the German-French Academy for the Industry of the Future. As you can see, many industrial partners have already indicated that they are interested and involved within this project, but obviously many industrial could join us for the next step. So we are hoping that this day will be very interesting in terms of exchange and future opportunity for collaboration. Thank you to everybody.
Thank you, Professor Delorme, for this presentation.